In the interior of the sun, gravity has compressed the matter to extremely high density. The core of the sun is very dense, about 150 times the density of water. Ordinary water that we would experience on Earth has a density of 1 gram per cubic centimeter. The material in the sun's core is about 150 grams per cubic centimeter. And it's very, very hot, over 13 million degrees Kelvin, compared to 100,000 degrees at the corona, or only 6,000 degrees at the surface. Millions of degrees Kelvin in the core of the sun. And this is where the fusion is taking place, and nearly all of the sun's heat is produced here in the core. This is where the intense heat and pressure is causing hydrogen to fuse into helium. And this is a nuclear reaction. And as the hydrogen fuses into helium, 4 hydrogen atoms merge to produce 1 helium atom. But if you were to measure carefully the mass of the hydrogen, the 4 hydrogen atoms have more mass than the 1 helium atom that they fuse into. So in the process of fusing hydrogen into helium, some of the mass disappears and it becomes energy. According to Einstein's equation, energy is mass times c squared, E equals mc squared. And that is the process by which the vast majority of the energy from the sun is created. It's from this fusion of hydrogen into helium. The same thing that's going on inside a hydrogen bomb. It's like billions of nuclear reactions going on simultaneously all the time inside the core of the sun. And all of that heat then travels outward to the surface. And it takes an incredibly long time to travel from the core out to the surface, out to the photosphere where it radiates away. And it first travels through what we call the radiative zone. And what's happening here is photons are traveling outward. But what happens is that they only travel a very short distance before they strike some of the matter in this zone. So this photon is emitted from one atom, and it travels a very short distance before it's absorbed and then gets re-emitted basically in a random direction. So these photons aren't simply coming outward, they're really bouncing around in all random directions, and they work their way outward through the radiative zone. In the convective zone, the heat is taken by convection currents within the gases of the sun. These convection currents, think of these gases as swirling here and carrying heat up to the surface, up to the photosphere. And to get from the core out through the radiative zone and the convective zone out to the photosphere takes 10,000 years or more. So the heat that is produced in the sun is trapped in there for a long time and slowly travels out to the surface. But eventually, of course, it does get to the surface and it radiates out as light, and that light moves through the universe at the speed of light, and from the sun to the earth it takes a little over 8 minutes. And then that light continues to spread out and disperse throughout the galaxy and throughout the universe.